Hi guys, how you doing? I hope everybody's had a great weekend. We are going to be talking tonight about making a talking skull. So I'm going to wait a few minutes till people start pulling in here. But grab yourself a beverage, get ready to have some fun, talk some haunt. Should be a good time. Okay, we have one. Okay, as you guys come in, if you have any questions, hey Mark, how you doing? Yeah, me too. I'm looking forward to this as well. It's always fun. Oh, crap. Okay, there it is. Back. All right. Mark, is volume coming through good and everything looks good? Trying to watch on my other laptop. And I think it's more distracting than help. Mark, how's yours coming out? Okay, good. Yeah, it cut out on my laptop too. I don't know what's going on. I keep losing it here, but I'm going to shut off my laptop. See if that helps. All right, guys, we'll get started. Still waiting for the parts. Okay. Now, you're doing a 3-axis, or you just doing a talking one? Remind me. You're doing a Monster Guts 3-axis skull? For those of you just joining, welcome. I'm going to be... Frozen, nothing at all. Mark, is it still live for you? Tim says he's frozen. I know he's been having problems working with a couple different browsers. Yeah, Tim, I'm getting your posts, so. All right, guys, while we're waiting for people to kind of show up before we really get started, I have done a sourced parts list. Hi, Missy. Hi, Corey. Okay, good. Looking like guys are coming in. It looks like maybe it's Tim's issue. But I've got a sourced parts list. If you want to go and pull that up, it's a bit.ly link. So you can type in bit.ly/TS parts. Can you guys see that? It's going to be backwards, isn't it? So it's a bit.ly link, bit.ly. Yeah, I don't know why why it keeps kicking in and out. Shut down my laptop. It's looking good on my side. You guys coming back in? Is it live? Not good. I don't know what the problem is, because on my end, it's looking like it's working just fine. Okay. All right. Live again, Tim says. All right. So, no, Mark will talk about those a little bit later. The OLED eyes. For now, this is just the parts list. Hi, Adam. For doing a talking skull. And what we're going to do primarily, what I wanted to talk about tonight is putting together a talking skull like this. And we'll talk about the mechanics and how to get this all installed, what it takes. We'll talk a little bit about the controller, at least that I use. There's a bunch of different options, but this just happens to be the one I prefer and the one I like to use now. So we'll talk about this, and time allowing, I'm happy to talk about 3-axis and the OLED eyes and all of that. In fact, for those of you that haven't seen them, hopefully his battery's still charged. We'll turn Jarvis's eyes on back there. So again, go over and you can get the Dropbox link for the parts list. It's bit.ly/TS parts. Talking Skull Parts, all lowercase. So go and get that, and it will have the sourced parts list for all the parts we're going to talk about for putting the skull together tonight. And then we'll actually add in, we'll talk about the OLEDs and the 3-axis stuff a little bit as we go on. So as you're getting that, what I wanted to talk about is this will be the base, doing a basic skull, and you can use lots of different skulls. The one that I put the link in is from Skeletons and More. That is the one. This is the same build that we did at the Halloween and Haunt Fest show in Dallas. My all-day seminar I did. We actually built these, and everybody left with a working one that they built, and that was the skull that we used. So that's the skull right here. Of course, the top of the head is down at my feet. But there's a lot of different. This works with any of the skulls. If you have Lindbergh skulls around, it works the same way with the Lindbergh skull. But we'll talk about how to prep a skull, how to get the servo installed, and how to wire it up. And then we'll talk a little bit about the controller, the wee little talker. And then if we have time and people want to stick around, we can talk about the OLED eyes, the moving eyes, the lit ones like Jarvis behind me has got, and go from there. So what you're going to start with, basic skull like this, and the way to make this whole install easy is using one of the pre-made brackets that, oh good, Tim, glad it's working, that I get off of eBay. This one's a black one, and the servo just screws down right onto the top, and as you can see, it's got all sorts of little holes on it there for all sorts of different mounting options. And what we're going to do is we're going to actually embed this down into some two-part epoxy that'll actually hold this into the skull. And we'll talk about some ways to even secure that even more if you're interested. But it all starts with one of these brackets. And again, that's you can go to the parts list. I put an eBay link that was still good a couple of days ago. To that, there's a lot of different ones on there, but that's one of the ones that at least you can look at and see exactly what that bracket looks like. And I think they're like $270 or something, maybe plus a little bit of shipping. They have some that come with the screws and some that don't. I think you may as well get the ones that come with the screws to be able to attach the servo to it. So that's what we're going to start with. The servo that I use, you can use any servos you want. Standard size servos fit into here. I'm a big fan of the high-tech servos. For a jaw servo, I am usually going to use the high-tech 425 BB. And if you're building a 3-axis skull, usually I use the 485 BBs for the head movements. But a 425 BB runs about $12 or so from Servo City, and has got plenty of torque for just driving the jaw. So that's what I start with, mounted up into one of these brackets. and with the arm on it that we'll attach the wire to in a little bit. So what you're going to do first is we need to form a nice stable mounting area and flat area for this to mount in. And if you're looking down on a skull, this is going to mount in here like this. And I usually mount these with this thing is dead center in the middle of my skull. There's a little knob right here, and I usually anchor the front of that servo bracket up on that. Now, some of the skulls, depending on which ones you use, you may have to actually get in there with a Dremel and actually flatten this out so that you get this a nice flat area for this servo bracket to be mounted in there. So if you have to, the Limburgs, not so much. They're pretty good the way they are. This particular skull, as you can see, here's where I'm going to try and lay the top of my servo bracket on, so it's got that nice solid area to set on. But it's got some raised areas up here in this front part of the skull that are going to require some work. So, I'll usually place my bracket in there and then take a black Sharpie and mark the outline of my bracket where it's going to need to go in there. And then take a Dremel with a grinding bit and just kind of grind that out until you get a nice flat surface for your mount or for your bracket there. Okay, everybody see that? And if you guys have any questions as we're going along, post them in the comments. I'll try and follow along and catch those as we go. So now the question is, how do we make this fit to this and stay there? And I'm going to give you a hint. If you've never used this product before and you're a prop builder, this is something that should be in every prop builder's tool chest or toolbox. I couldn't build half of the props I do without this stuff. This stuff is magic. You can't read it. It's backwards. It's Propoxy 20, and I put a link actually on that page for Propoxy 20. This stuff is a two-part moldable epoxy. You take it, you cut off a piece, mold it together until it's a nice even color, nice and gray, and you can mold it down in here, make a flat area, and then actually just without the servo in the bracket, embed this down in there, work some of that epoxy down into the holes of the bracket, and it will be a permanent bond in there. And this stuff is magical. I use it all the time for making platforms and extensions and filling things when I'm building a lot of these props. Once it sets up, and it sets up pretty quick, 15 minutes or so, it's sandable, it's fileable, it's drillable, it's tappable. So you can actually, if you still want some more rigidity and aren't comfortable just with having this thing glued down into that epoxy, you can actually, drill a couple of holes in these side holes here and tap and drill so that you can actually attach a couple of screws there. If you want to make your servo bracket removable, you can do that as well. You just Vaseline this side of it up really well, set it in there until the platform, the bed, is all nice and solid of the Propoxy. You can take this out, use it for something else if you need it, but you can put it in, then actually drill and tap those holes. So now this bracket is removable. So again, when I'm going to put it in, I'm going to make a nice base for that in here, and you can see the gray Propoxy kind of sticking up here around my black line where I had traced. And I'm going to make a nice bed for that, and you can see screws here as I actually did drill and tap for 4 screws down here to hold this in. And if you put the front of your bracket in on that little knob that I showed you, it actually lines up your horn about in the right place. Using digital organs into your work. Johnny, give me a little bit more detail what you mean by that. Okay. Yeah, and Tim, also, I've used some of this other two-part epoxy. I've used some from Home Depot in the plumbing section and stuff. I have never been as happy with some of the other brands as I am with Propoxy. I don't know why. Maybe I just got some bad stuff or I didn't use it right, whatever. But this stuff has never let me down. I've been really, really happy with this stuff. So if you've got another one, try it on something that you're not quite so worried about. And if it works, fine. If it doesn't, you might want to switch to this. Okay, so now once you get that thing placed in there and that solidifies, you're going to need to install your servo into the bracket. And as you can see, you don't have a whole lot of room to work up here with the screws. Hold on. I put in some short screws and nuts on here. Sometimes you have to get a little creative with being able to get your screws in there. But you can get, if you're using the screws, you can put the screws in, usually be able to get in there and hold it and take a tiny wrench and get these nuts into the back end of it. Okay? And you are going to place your servo. If you look at your servo, the horn, the mount for the horn is not mounted dead center on the servo. It's mounted off to one side. And when you install your servo into the bracket, you're going to want to do it so that the mounting part is towards the back of the skull. Not up here at the front. You want it back here on the back side. Okay? Can we all see that? Now, I like using the red horn. When you buy the high-tech servos, they come with a bunch of different horns that you can use. I like this one. This one actually comes 4 pieces as a plus sign. I cut the other 2 off and just use these 2 on there. Okay, and it's nice for me if I leave the second one on when I can manipulate it by hand. Okay, so you're going to get that servo installed. You're going to put your servo horn in. Now, the funnest part or the biggest trial, toughest part of this whole process is getting this hole for this wire. You're going to be using some pin wire, and I got this pin wire for mine from McMaster Carr. It's fairly stiff piano wire, but it does have a little bit of flex to it, and it works really good. Yeah, we'll talk about it, Johnny. Okay. And I bought a package of 100 of these, but of course you don't need that many, but I've used it for different make and takes and stuff. So this pin wire is actually going to go straight down here, and through the skull you're going to have to drill a hole, and it's going to attach onto this point on the skull, right there. On this little knob, you're just going to drill a hole for this to go through. So what you're going to try and do is, by sight, try and line up this line between that point and between where your servo horn is going. Okay, can everybody see that? Is that coming through? And translate that into the inside of the skull and drill a hole through the base of the skull there. Now, don't worry how big that hole has to be. You know, I usually use a 1/4-inch bit to start, and usually end up enlarging it multiple times with my Dremel to get that so it doesn't bind at all. Nobody's going to see that. You know, when you've got this thing mounted on a prop, nobody is going to see that hole back up underneath there, back here. So, you know, don't be afraid that it's not lined up perfectly the first time. If you have to keep enlarging it, you know, that's no problem at all. And so you're going to do that. The other thing, you're going to still have to drill a couple other holes. What I do with my skulls is a lot of times the mounting part on the jaw is not very secure. So what I do is I actually drill a couple of holes. You can see right here above each of these pins on this particular skull, and then drill it through here and attach this with wire ties. And then you're not having to rely on any connection. You know, some of these kind of are shaped so that they fit in there, but over, you know, hundreds and hundreds of times where we're using this and this guy's talking, that always seems to wear out. And this method works a whole lot better. And then you can just keep tightening up that zip tie until you get that jaw just where you want, where it's tight enough that you get nice movement, but it's not tight enough that it binds it all. Okay, any questions on that? So, once you get your jaw attached back here with the zip ties, and you get a hole drilled through the top of the, or through the base of the skull here, you're going to need to attach your piano wire, or whichever wire you're using, to your servo. Now, a couple of things. Eyes are falling out, excuse me. Surgery. Get back in there. You need to kind of figure out how much you want your jaw to open. A lot of people that I see build talking skulls feel like they've got to make their jaws drive all the way open like this. To me, that looks like a duck. So if you look at any of my skulls, and again, if you want to see some of mine, you know, I've got a lot of examples on my website, Hallstaff's Animatronic Workshop on YouTube. Go over to YouTube. You can catch a lot of the videos over there and see. But for me, driving the jaw about this much is more than enough movement for me. I think that gives a pretty realistic look. And when you set your jaw, you're also going to want to make sure that it's not driving all the way shut. This makes a ton of noise. It's bad enough dealing with servo noise, but the jaw hammering together like this, to me, is a whole lot worse than the servo noise. So, you know, I'm going to usually leave my jaw when I get it set on my controller, so it's just got a little bit of a break here, and it's only going to open about that much for me. Even a yell with the mouth open that much, I think is sufficient. So don't feel like you've got to really, you know, get this mouth so it, you know, just looks disjointed. You know, this much movement in one of these jaws is just plenty. Okay? So you're going to want to attach this pin wire. For the attachment here, I just bend it over, put it from the outside in. Actually, I did it the other way. Came from the inside, went out, wrapped it around, and then cut off. Let's see, can you see that? I don't think I can get you an angle inside there. There we go. Just bent it over and then cut off the excess here. For the other side, that attaches to the servo horn, you're going to want to make a little L bend on it like this. Let's see, the best spot. That look good? Now you can do that with a couple pairs of needle nose pliers. I cheat. This is a cool little tool if you've never seen one of these. You just put it in and squish it, and it makes a nice little bend. You know, it's all about the tools, right? If you're going to do a new project, you got to always buy a new tool. There's always an excuse to buy a new tool. It's a good excuse. So this is the end that's actually going to fit into that horn. It fits in and goes down, and this is going to be going down through the skull. You're going to bend over the other side at the right length. When I do these, I'm usually going to set the distance with the mouth closed. I'm going to have this set through my hole. I'm going to have my servo set not all the way to the top. I want to leave myself a little room you know, maybe about like that. Put this down, and then you can measure, cut most of this off, and then make your bends through this spot in here in the jaw. And I just try and get into the meat of this piece here. And if this really bothers you, you know, paint it to match your skull. Nobody's going to ever see it, but if it bothers you, you know, when you stain your skull, you can color that a bit. So that is going to set your wire to drive your skull. And then you just want to make sure that you're getting nice, smooth movement through that. Any questions? Comments? Cooking recipes? Nope. All right. So with this particular one, I want to talk a little bit about the controller. The controller I use is one that Steve Bjork has put together. This is his wee little talker. We've done lots of controllers. I've done my Frankenstein 3-axis controller. Steve's developing the new Banshee. Okay. Tim, it sounds like it's good. It's you. But this is the wee little talker. This board doesn't do a whole lot besides drive a jaw and provide power for eyes, which is, we simplified some of the 3-axis controllers just for this exact process and this exact project. So this is the wee little talker, and when you use this, it also allows you to have eyes on here too. So I'm going to talk a little bit about putting eyes in, lit eyes in these. These are not 2-axis, they're not moving, they're just lit eyes. So, a couple things with the eyes. I put a link. Did everybody get the link for the parts list? If you didn't, go to bit.ly/TS parts, so it's bit.ly/TS parts, P-A-R-T-S. Okay? And that'll get you the source list, parts list that I use when I do this build. Actually, these are the eyes that I use, and I put the link on there for them. And if you look at these, they've got a seam right down the middle, right wrapping around here. And between the eyeball and where I've got the LED, there's a hollow section. You can kind of see that cross section in there, that hollow space in there, that you're going to actually insert the LED into. Okay? For those of you that haven't worked, well, we're talking about LEDs. To drill this, to get that hole, this does not have a hole in the back of it when you get the eyes. You need to drill this hole right here for the LED to fit into. And it can be a pain. Got you, Tim. I'll get to it in a minute. It can be a pain getting this thing centered, holding it on your workbench, trying to get a drill in there and hold it. So I'm going to teach you a little secret here. This makes drilling round objects, centering a hole in a round object, a breeze. What you do, I've got this block, and it's big enough that I can clamp it onto the base of my drill press. And what I've done is I've drilled a hole with a spade bit, and if you don't know what a spade bit is, it's a bit like this, and this is a 13/16 spade bit, and I've drilled about halfway down into this board. Okay, can everybody see that? And then, once you do this, you're just going to have a little triangular hole right in the center. What I did is then took a 3/16 inch drill bit, which is the size of the drill bit for a 5mm, my 5mm LEDs that I use, at least, you need for this drilling that. So I drill this all the way through with the 3/16 drill bit. So now it's really easy to put this on my drill press, bring down the drill bit, center it on there, clamp it onto the base of my drill press, and then it's super easy to just set this thing in there. You can use that center seam to get this in here straight, and now it's a simple process to hold this, bring your drill press, pop it right through into that void, so that you can install the LED. Now, 3/16 drill bit for my LEDs, and it should work for all 5mm LEDs, is a little snug, but that's exactly what I want. I don't want that LED to have to come out, and I don't want to have to glue it in. So if I use 3/16 with this rubber, that forms a nice tight bond in there. So now you're going to need to wire these up. We'll talk about that too, Adam, in a second, about the pneumatic heads, or pneumatic bodies. If you've never wired up an LED, usually if you're wiring these up to 5 volt, 12 volt, and you wire an LED directly to that, you will blow the LED. It can't handle that much power. So you usually have to put a resistor in line, and what size resistor depends on, what you're using for a power source, but usually you have to put one in line. Steve has done that work for you, for us, so he's already installed the resistors on here. So all we have to do is directly wire this to be able to hit onto or connect onto the board. And there's a couple pin headers that we're going to install the eyes onto right here. And the easiest way to do that I know of is to, thank you, Tim. Yeah, you guys can help answer questions anytime. I'm always up for the help. So please join in and join in with your ideas. I certainly don't have all the answers, and I can certainly enjoy learning from you guys as well. So please participate in the comments, especially if you've got an answer to somebody else's question. But what you're going to want to do is get a servo cable, one servo cable, about a foot long. And what you want is a servo cable, not a servo extension. And most of the ones you see on eBay, if you go looking for them, you're going to... I got to stop shaking up. It's going to be a servo extension. So when you get a servo, it comes with this... Take some of these out of my hand. With this header on it. A little male header. 3-pin male header. And for an extension, it has got a female side that this is going to fit into. Make sure I line them up right. Make sure the wires line up in the correct. Okay, and that's how you extend a servo cable. Everybody see that? This is not what you want for the eyes, though. You want an actual servo cable that's going to have 2 male ends, because what we're going to do is we're going to cut this in half. We're going to use one for each eye, and then these are going to plug right into your servo headers on your wee little talker. Okay? So you're going to get one of these. You're going to cut it in half. These are actually the 3-pin headers that I've got with me here. What you really need for just the eyes, you only need a 2-wire one. They're just like this, but they don't have the white wire. They just have a red and a black. I just happen to be out of them, so I couldn't show you. But you want one that's just got the red and black 2 pins. So you're going to have a red wire and a black wire coming off of this. So here's an example. Here's the one on this skull. So it's going to look a red and a black 2-pin header, just like that. Okay? So you're going to take one end of that. You're going to take those off, strip off the ends, cut it in half, strip off the wires. And what did I do with my eye? Yes. You're going to have an LED. If you've never wired up an LED, we're going to briefly go over this. As you can see, the LED has got 2 leads on it. One's longer than the other. Can you see that? One is longer than the other. The long one is the positive, and that's what you're going to hook the red wire to. The short one is the black one, so which is the cathode, if you want to know the technical names. Anode for positive, cathode for negative. But all you got to remember is red goes to the long one, black goes to the short one. If you solder these up and it's backwards, don't worry about it. Just turn the header around the other way. If you plug this in backwards, it's not going to harm the LED. It's just not going to work. So just flip your header on the board. It's going to be backwards, but it'll work then. So you're just going to solder in those little the wires onto the end of this, and what you'll end up with is each of the eyes is going to have one of these cables then coming off of it that's then going to plug into the wee little talker or into whatever other board you're using. Okay? You may have to, let's see, did I? Some of these eye sockets where this wire, you know, you're going to end up having you're going to end up with the eye like this with this connector on the other side. Sometimes the eye sockets in there are not quite big enough to put this 2-pin header in. You may have to drill that out just a little bit to be able to sneak that thing back in. But easy enough to do. Sometimes not easy to send it back in there. All right. Yeah, Tim, there are some great LED calculators on there. The one I like, let's see, I think I've got it. Let's see if I've got it somewhere. I'll have to find it. I thought I had it here listed, but I don't see it. Oh, I do. Okay. So if you want the LED wizard that I do, again, it's a bit.ly link, bit.ly/ all caps LED and then lowercase WZRD. Okay? So bit.ly / LED in caps and then lowercase WZRD. With bit.ly links, if you're first time using them, they are case sensitive, so you have to pay attention to that. No, Mark, the eyes do not move. They just, on this particular one, they just light up. Okay? And when we get done here, I'm going to go for a few more minutes. I want to talk about the wee little talker, and then we'll talk about the eyes that I use now to move. I've done a lot of 2-axis eyes that move with servos. And as you can see, some of the issues with that is once you get this servo installed and the wee little talker board is going to actually fit back here and fit inside the skull, there isn't a whole lot of room up here. You need to do a lot of different things to rearrange to be able to get the little servos and all the mounting hardware and brackets and everything to put servo-driven eyes in here. You'll almost have to put a plate in so that you can have this servo sitting on top of the plate and the eye servo sitting underneath the plate. So you've got 2 levels. So that adds a whole nother level of complexity to it. And when we're doing even the OLED eyes or the TFT eyes, we have to do some different things because we need to be able to set those screens back in here in the back of the eye sockets, and it takes a ton of grinding and removal of material to be able to get those screens back in here. So if you want moving eyes, that's a considerably increased level of difficulty. So now I don't know how many of you guys know how to solder or like to solder, but again, if you want to buy a kit, this is the wee little talker. I think this board, with buying all the components, the sound card, and everything, is about $30 to $35 for the parts. You still have to solder it together. If you buy the board from Steve, and I put there is a link on that sheet. He does include, in addition to the board, I think that is $18, a couple of the other components that are difficult to get or you have to use a different supplier for. He includes them in the board so that you don't have to pay shipping to 3 or 4 different places. If you're going to use the boards that we use, most of our stuff is pickaxe based, which is just a type of microcontroller. And for the first time, you're going to need to buy a cable. And you can buy that the same place that you buy this pickaxe chip. The cable's about $21. and I think Steve has it listed, the link to that in his parts list for the Wee Little Talker. Again, you can download the build list for the Wee Little Talker right off of his website. And, oh, it looks like my batteries are dying in Jarvis, in his eyes. It's the first time I've seen the batteries go out as I had them running. Interesting. Okay. But you'll have to add a download cable. Now, you don't have to write any code for this, but you do have to load it into the board once you build the board. The editor for the programs from Pickaxe, that editor is free as well. So, it doesn't cost anything to get the Pickaxe editor. Get the code from Steve, you download it, open it up in the editor, connect your board to your computer, and just download the program in here. Steve's got the program all written. You don't have to do any programming at all. But you do need that cable. And plus, you're going to want it anyway. Steve is continually updating and improving the software on his programs, just like I do with mine. And, if we do an upgrade with the program, we want you to be able to get it. And you're going to need the download cable to do that. So anyway, that's that. I'm not going to go too much into the programming of the Wee Little Talker. That's a whole different subject. But just to basically do it, much like if any of you guys have seen my Frankenstein board or Steve's Banshee board, the setting of the limits of your jaw servo, I talked about this, and what you're using for a trigger, whether it's you want it to loop or you want to use a PIR or step mat. You turn this on and it has audible prompts that walk you through setting those limits up. And all you're doing is following the instructions and pushing the buttons. So it may say, I want to set servo limits. So it says, all right, open the jaw all the way up, and you use the plus and the minus. You open it all the way up to where you want it and as a limit, and you set. Then it may say, all right, set the closed position, and you do the same thing. You move it up, get it closed, set. That's it. That's all you're doing. So it's really easy to set up the limits. 3 minutes, 5 minutes max. And you'll have this board once you've got it programmed up and running. Get your limits set, the volume set, what kind of trigger you want, what you want for a prop trigger delay. The way we set our props up, usually when they trigger, it's got a delay once the routine is done, at least 20 seconds, 30 seconds, but you have a lot of choices. Steve gives you a lot of choices up to a couple minutes, I think, to do that. One other thing with using this board, with some of our older boards that we used to use, in order to drive the servo that drove the jaw, especially if you were using an audio track that had music in the background, if you just fed that full track into the controller, it would use everything, every drum beat, every volume change, and the jaw would respond. So the way we got around doing that is we split a stereo channel. One side of the stereo channel, say the left, went to your speakers, and that's what everybody heard, and the right channel actually went into the controller. And we had to actually go into a program called Audacity, which is a free program, but we had to actually go in and set tones that would actually drive the jaw. You'd listen to the song or listen to the spiel that he's doing, and every time you wanted to drive the jaw, you'd put a tone in, and you could vary the width of it. So depending on, if he's going, ah, and you'd put a nice long tone in, and then you'd close his mouth back up again. You don't have to do that with these now. Steve's got this. This automatically takes the spiel. Again, it's splitting the tracks, but it's using that, and it's automatically figuring out how to move the jaw. So no more having to go into Audacity and go through all of that to do it. Again, 5 minutes once you start, you can have this thing up and running. So yes, Tim, as far as using a digital, you're going to set limits when we're doing jaws anyway. So that's why the 425, which is not a digital servo, works just fine. We don't need a digital for this because we're going to actually set the limits not with a servo or a programmer. And for those of you that aren't familiar with this, if you're using digital servos instead of analog servos, they're a little more expensive. They've got some other advantages, but you can use a programmer like this one, and you can actually set the limits of the jaw. You can reverse them. You can change the speed on them. One of the reasons we really love digital servos. They have greater holding power, but digital servos are great for a lot of things, like building the upper bodies. But for this, an analog servo like the 425 is going to be just fine because you're going to set the servo limits through the board. Okay. Tim, it's really good. Steve uses the X series of chips, which are better than the M's from Pickaxe. So they limit. Will, I started. I confirmed with you first. This series of chips is much better, and if Steve is on, maybe he'll even chime in about not having chattering. If you're having chattering problems with your servos, oftentimes with mine, I try and isolate, like on Frankenstein, which is a 3-axis controller. I isolate the power supply that drives the servos, so I'm using 2 power supplies. A 12-volt power supply that drives my audio board. It's reduced down. It drives my Pickaxe chip, does all the other stuff to drive the board, but the servo power is supplied by a different power supply, and which is really nice if I'm setting them up that way, because some servos, they'll run 4.8 to 6 volts, and some of the little tougher servos will run 7.4 volts. So I can run a bigger power supply. So it's easy enough to just switch out power supplies and run the big power supplies, like if I'm doing this. And the reason I'm going to want to run a bigger power supply, right there, is I'm going to get more torque out of them. So more lifting power. So that's that. Any other questions about this? I'd hope that we'd keep this under an hour. So if there's any other questions, the other thing is, before I wrap this up, what do you do with the skull once you've got it up and running, and how do you attach it to something? A lot of us are using, you're going to use PVC. This is going to set on top of a character that's maybe got PVC. So that's what we did with this. I'm just using a 3/4, or this actually is a 1/2 inch extension that goes in through there, and I just use a 1/2 inch cap on the other side and just press those together. They happen to fit in there nice and tight on this particular hole on this skull. If you have a skull that's got a much bigger hole, you may have to use a washer. I've used some great big fender washers before, and cut off or ground off the sides, to form a bigger plate here for this piece to set up against. Or you can, if you're going to be hooking it up to, and you need threaded rod, you can run 1/4 inch threaded rod up through here. Again, with a big washer here on the bottom, coming up, another big washer on the top, and then lock nuts on the top, and you can run this with threaded rod on it. We had a question a little earlier. How's a talking skull going to work out on a pneumatic prop that's got a lot of action to it? Talking skull, this is pretty secure. If you build them with the zip ties holding this on, let me find the skull cap and I'll show you. And you use the zip ties in here. That's a pretty secure attachment point. The wire here is not going to come out. You've mounted this thing very securely, especially if you tap and add a couple screws like I've done. I put actually 4 in. This one's never coming out. But that's a pretty firm connection. What you're going to do, if I'm just putting this on a static prop, then I can set this just on the top and put the skull cap on and not worry about it too much. This is the piece I'd worry about more. If I'm going to put it on a pneumatic prop, I would probably not put the controller in the skull. What I would do is run cabling down and put this on his back, or put this even off the prop, so that my controller's not banging around. This actually worries me more, as far as all that activity and bouncing around and being pounded, than this stuff does. So I hope that answers that question. Yeah, where's my skull plate? Yeah, for these particular, you're gonna, when you're building these skulls, you want the ones that have the removable candle, whatever the top of the skull is, and they're just, it just fits on here, just on top, and then it's got a couple little latches that latch it on. Okay, that answer your question, Kathy? Oh, Steve is chiming in with the chattering issue about the jitter, so you can check that post out that he's got down in the comments. So that's that. We talked about the eyes. As far as the eyes go, as you can see, mine are not glued in. I usually just put these in, do my best to center them, and put a little bit of hot glue in there. And it's clear, and it firms those up, and so your eyes are going to stick in there. Okay. Any questions about the skull? And we've got a few minutes. We can talk about some of the other stuff. Yes, clear silicone caulk as well. And right, if you want to do that, you can put this on. One of the problems I have with these skulls, and if you've seen my characters, you know, we go into pretty great detail with sculpting these, is I hate that friggin' line right here. We're actually looking at taking some skulls and permanently gluing this, sealing this, sanding it, and then cutting the back of the skull, much like Fright Props does with theirs, and cut them back here to access them, to work on them. That's something we want, because I hate that line. And you can't permanently seal these up, because you may have to go in there and replace a servo or do something, you know, some maintenance. So they have to remain removable. But like Tim said, if you put clear silicone caulk on there, you can seal that up, and then when you need to get in there, you just take your razor knife and cut that and separate them back up. Kathy, there's a ton of it on my website. You know, I've got, I don't know, over 100 videos over there, a lot of tutorials over there, on how I've built a lot of my props. Of course, the forums, Haunt Forum, I'm a moderator over there for the Tech Forum and the Pneumatics Forum. So, you know, that Halloween Forum, Garage of Evil, there's great forums over there. Facebook has been wonderful for a lot of things, but it's leaves a lot to be desired, in my opinion, as far as doing tutorials and this type of stuff. Things get lost on there too fast. They're harder to search. So I really like the forums. I still am really active on the forums, because I think it's a much better area for us to discuss things like this, share ideas, share techniques. So check out a couple of the forums. Like I said, I'm a big fan of Haunt Forum. A lot of my tech buddies participate over there on that particular forum especially. So yeah, and as Steve says, you know, both Steve and I are instructors at a lot of the different conventions. Steve is going to be giving a talk up at West Coast here in a couple of weeks. I'm going to be, I was just at Transworld giving a presentation. I will be in Dallas in August for the Halloween and Haunt Fest convention, doing a lot of the same type of stuff there too. So if you can make the conventions, that's a fabulous place to get more of this information. Okay, excuse me. Still getting over that cold from last week. Any other questions on any of this stuff before I branch out a little bit into the eyes and the 3-axis that we've had some questions on? I hope I've given you some tips and some hints about making some easy things to really make your life more simple when you're out in the shop building this stuff and putting some of this stuff together. We had a comment about how hard it is to put multiple servos into a head when you're trying to get not only 3-axis and a talking skull, but you're trying to get eyebrow movements and cheek movements and lip movements. You know, a lot of times 11 to 15 servos in there. And so this is how I'm going to do mine. I'm not installing the servos in the head. I'm going to be using cabling. So you know, this fits in here. Try it the other way. It's going to fit in here. It's going to drive this cable, and and my servos will be mounted outside of my head, and the cable end will go up there and drive my different motions. So that's how I'm going about it, because I'm not really interested in building all of that stuff to try and squeeze 14 servos into a head. I think that jigsaw puzzle, I'll leave that to other people. Okay, any other questions about the head stuff? We'll talk a little bit about the fancy eyes, and I wish my battery wouldn't have died, but I had it all on last week, and I didn't plan on turning it on tonight. So the battery, it's got, I don't know, can you see that? A little 500 milliamp battery in there that actually runs them. And he ran, somebody asked me last week how long he ran on these batteries. So he ran, last week we had the whole show. He was on the whole time for that. And he lasted, at least half of the show tonight on one charge on that battery. So, yeah, you know, one of the things that's really nice about doing steampunk as far as hiding things is, yeah, we can put rivets, you can put steel braces and brackets. Steampunk is wonderful for hiding, being able to hide seams and everything, which I really like. So we had a couple of questions about the lighted eyes. The link is over on Adafruit. We posted it last week. And if you check, somebody will go and look and let me know if this is the right one. Another bit.ly link, bit.ly/ADAKIT. If somebody could type that in for me and check, and I think that's the link for the tutorial on making those lighted eyes. I don't have any plans to ever make 2-axis eyes again, now that we have these eyes. I think they're much more, I'd rather build these for one. They're easier to fit in, and for what we do with working with our props at night, having them already lit, the eyelids move, you know, to be able to do movable eyes and movable eyelids, you're looking at least 6 servos, 6 or 8 servos, to make all of that stuff happen. And I'd much rather use these eyes. I really like them. And I do not use when you do that build, that project, there's 2 choices for the little 1-inch screens. They're the OLEDs, OLEDs, and they're about $40 a screen, so $80 for the 2. Or you can use the TFT, which are $15 a piece. I've built both. For what we do, I think that the TFTs are perfectly fine. The OLEDs are a little crisper and cleaner colors. But for the cost savings, all I build now are the TFTs. So I haven't spoken to many of the Japanese guys, but just to let you know, for those of you guys that don't know, I do write a monthly column for Servo magazine on do-it-yourself animatronics. I've been writing that column for a couple of years now, and Servo magazine's just put out their first edition in China, and I'm supposed to be in the next issue. So my stuff will be in China. So I've talked to some of the translators over there, but not any of the robotics guys. I do participate in a lot of different groups, robotics groups, cosplay groups, all the Halloween groups. You know, there's a lot of the Christmas lighting group, tons of information over there. But you can get a lot of this information. You don't always have to recreate the wheel for all of this stuff. So, yeah, I know Disney is using a lot more of the video eyes. These little screens now have become so reasonably priced that it's just fabulous. It's a great effect. I'll tell you, all the stuff I built last year, that was what I got the biggest response from. People were the most impressed with were those video eyes. Did have a couple of questions this week. I wanted to answer them really briefly, although we weren't going to cover tonight. But 3-axis kits, still the one I like the best. We don't have a whole lot of choices out there right now, but the kit that Monster Guts puts out, I've used it a bunch. I think I have 2 or 3 of them. Very clean compared to what we used to use. That right now is my favorite. They're just for the kit, not including the servos, it's about $100. So it's a little bit pricey, but that 3-axis is really cool. His instructions to install them are pretty thorough. Just one thing I do want to mention: if you're building yours for the first time, a Lindbergh skull has got a hole on it that big. You need to about double the size of this hole right here to be able to get nice movement so that none of the bars hit as this thing is tilting back and forth. So I think it takes a 2.5-inch hole saw. The biggest I had before was a 2-inch, so I had to go out and buy one. But just be really careful when you're drilling down with this. When you're cutting this with the hole saw, it really has a tendency to heat up and grab onto this plastic and rip this skull out of your hands. So my preferred way now is to set this on the plate of my drill press, have somebody help so that we can get a nice secure grip on it and just be real easy, come out and clear the debris out of this hole as you're cutting it, because that can be a really pain. It can be a knuckle or wrist breaker when you're trying to drill this bigger hole in the bottom. So that's one thing that I don't think I've ever seen anybody mention before, but it can be a real issue that I wanted to mention. All right, I'm right at an hour, right where I wanted to be, which is strange for me to end up on time and not still have things to talk about. If you guys have any more questions, post them in the comments. I'm willing to stick around here for a little bit if people still have questions. Did you ever corpse your talking skull? Adam asks. As a matter of fact, thank you very much for asking. As I said, we did this build last year at the Halloween and Hauntfest show in Dallas. And William Ramsey, who's another speaker, was also there, and he was doing his corpsing a skull presentation. So this one I have yet to still put my stain on it. But what they did is we had my all-day seminar on Friday, which included the build of the skull and everything inside of it. So this is the one. So people were able to do this, and then they went to Bill's class on Saturday and actually did the corpsing. And this is using the plastic wrap, and the heat gun method. And they did that. And you just had to make sure that you still made sure that you didn't tighten this up so much that your servo couldn't drive the jaw. And then once this is done, then you put gel stain on here and stain them up. Tighten that up a little bit. Okay. So that's how we've done these. Okay. And again, the skull still fits back on there on top when you're done. Yeah, I wasn't able to stain mine when I was there because by the time I had time, it wouldn't have dried in time for me to put it in my suitcase. So it has sat on my shelf just waiting for Adam to ask that question. So, yeah, Tim, that becomes another thing. The more servos that you have, you still have to, doing the build and the mechanical stuff, I actually think for a lot of this stuff is the easy part. The hard part is doing the actual control. It's just like Jarvis. I've built Jarvis up to take to conventions with me, and it takes me, again, he's all battery powered, so he can run up and down the hallways, and I can control him. But it takes two remote controls. I've got one that's a 4-channel controller that just controls the GoPro. So I've got the GoPro on a pan and tilt up here, so I can control the GoPro. And then that takes out 2 other servos on that controller. And then I've got another 12-channel controller, and I think I'm using 9 of those channels to control all the arm movements and everything. And so it still takes 2 controllers. The head is still controlled with a Banshee. I'm using Steve's Banshee board to get my random motion for my head, and then I am using a wireless mic that comes into a speaker here, and through the wireless mic I'm driving the jaw. Again, using the Banshee. Steve did some custom software for me that through a wireless mic I can now control the jaw. So I can have this guy running down the hallway, 75 yards down. I can see exactly what he's seeing through the GoPro, and then I can talk to people through the wireless mic. Yeah, Corey, we are planning to do it next week, 5 o'clock again. I think that's time seems to work out. 5 o'clock Pacific, 8 o'clock Eastern. We'll do it again next week. I'm not sure what the topic is. If you guys have any suggestions, make sure to leave them in the comments, and I'll, even after the show, you think of something during the week, post it over on my site, and we'll figure out. But I haven't picked a topic yet. So if there's something you're dying to see, we did this. We had a lot of questions on the Talking Skull last week. So that's why we went with this tonight. It was on a recommendation or suggestion from one of you guys, or a couple of you guys. So that is that. Questions about the eyes? Anything else on 3-axis? Again, for the 3-axis, I am using... For a lot of my boards, I use my Frankenstein 3-axis random head controller. We are slowly starting to shift over to the Banshee board. Steve is going to have that. Actually, he took the Frankenstein so that we could, and has improved it, so it will eventually be able to control 2 skulls talking back and forth to each other. Which is going to be a huge, wonderful feature. So that's what he's working on that. And I think he's just finishing wrapping it up. Steve, if you're still on here, make a comment if that's actually up and running yet or still a little bit of ways away. So, yeah, me too, Corey. I'm always learning. And a lot of guys ask me, are you an engineer or a programmer? I'm a real estate broker. I learned how to do all of this after I got into Halloween, and I spent a lot of time on the internet. I learned how to program. I learned how to design my own circuit boards. I learned how to do all the mechanical stuff through the forums and YouTube and the internet. So there's just a ton of information out there, and I love sharing it, love seeing what you guys do, take this information and bring it to life in your own haunts. So I'd love to share. And again, if you have questions about something specific, let me know. If you've got an idea for a topic, post it on there. Go over to my YouTube channel if you're not already subscribed. Subscribe. I'm always trying to put new content up over there as well. Like I said, there's over 100 videos on there with a lot of my different props that I've got built on there. So yeah, the aluminum mounting plates, I used to design all of my own and spent a ton of time in my workshop cutting and working and forging all of that stuff. But now I'm pretty much hooked into these Actobotics. The time it saves me building my characters, the bodies of my characters is so substantial, and it allows me to do a lot more and focus more on the programming stuff. Again, if you want more information besides my YouTube channel. You guys already know about the Facebook channel because you're already there. But also, check out Servo Magazine. The last 2 years, I've been writing articles on do-it-yourself animatronics, covering all of this stuff. And if you subscribe to it, you can get the back issues if you sign up for the digital version, and you can get the past 2 years, or you can be patient and maybe wait for the book. So I am working on compiling all of that into a book. We'll see if it happens. I'm not holding my breath, but hopefully it will be happening in the near future. I've been putting a lot of effort into doing that, and right now it looks like it's going to happen. We'll take the first 2 years of my articles from Servo Magazine and compile them into a book, and I think it's a pretty thorough prop builders introduction. Not just introduction, but it has a lot of these projects in it that we've been doing for the last couple of years. Oh, Mike, glad you could join us. Say hi to Dan. He's not on tonight. He or Allison. I don't think either of them are on tonight. So, yeah, I got to wake up the West Coast guys, Steve. Will forgot about the time change, too. So, hopefully this time works better for everybody. I know the East Coast guys, it's a lot harder to get on here when we start at 6 o'clock our time, 9 o'clock your guys' time. Even if we are able to keep it to an hour, it's still 10 o'clock before we're done. So I think we're going to stick with this 5 o'clock Pacific, 8 o'clock East Coast, at least for the time being. All right, any other questions? Hi, Paul. You guys are all coming in late. If you missed anything, for those of you that forgot the time change, it's of course going to be on the Facebook page sometime this week, depending on when I get my writing article stuff and get my editor off of my back. I'll put this together and have it up on my YouTube page as well, like I did last week. So if you missed last week's, it is not only on the Facebook, but it is on my YouTube channel, all in one piece on YouTube. A lot easier to watch over there now. So, yeah, Michael, I saw that you had yours. Nice to see those three. Once you start building 3-axis, it's hard to go back. I will. Yeah, Miles, I hear you guys had a bunch of flooding people that you were dealing with, you and Susan. And my heart goes out and my prayers go out to all of those people that have been impacted by all that rain. If you guys want to stick around, I will talk for a couple more minutes about something else for 3-axis. The 3-axis from Monster Guts is great if you're using a skull. But there are a lot of times when we don't want a skull. We want to use something else. We've got a cool mask or something. And this is the 3-axis mechanism I use for my masks. Now this particular one, I wanted to, since this is a model that I take with me when I travel to teach. I had it in Transworld with me without the head, but he'll be in Dallas with me. I wanted to make it with plexiglass, but usually I'll just use plywood for this head. But I cut this shape to fit inside the mask, and then what I do is take some foam, some tombstone foam, the high density foam, and cut and form some pieces that I then attach, usually glue onto the plywood onto here to give body to my mask. And sometimes I'll even put it like on my witch. She had a big chin on, and so to help drive the jaw, I have a big foam piece that fits down into the bottom of the mask. So I've got a servo right here that is controlling your nod or your tilt, or your nod actually is back here. And you can use a servo for this, but a lot of times you get a lot of weight up here on the front end with a big mask, and it takes a tremendous amount of torque back here to get your nod back and forth. So I really like these little actuators. These hook in just like a servo does. They have feedback just like a servo. They fit into our controllers. And I'll tell you, you will have no problem with torque on your nod here. You know, a lot of times we'll get these, and with the 3-axis, you'll notice your head goes down, and then your servo struggles to lift that head back up. If you're using one of these actuators from Actuators, never will you have that problem again. So I've burned out some servos, some nod servos before, asking too much of them, but ever since I've been using these for these masks, I don't have a problem. And I really had to start using that with Jarvis. And let's see if I can get him turned around without breaking him. Can you see him? Yes, you can. If you can see how I've got his head mounted on the frame, so the nod, all that weight is mounted up on the front end. Get him back there. So there was even installing a spring back here to help. There was no way I was going to get anything less than, you know, a $200 servo to be able to get that nod to work the way I wanted. So that was the first one that I went with the linear actuators on there, and it works so well that that's just the way I build them now. So so that's what I do for a different version of a 3-axis if I want to use it for a mask. Okay. Tim, those linear actuators, they're Actuators, Actuonix, I believe. I don't know if I have a link. Looking. If you can't find that, let me know and I can get you a link for that. Tim, shoot me a message over there on the on Facebook, and I can get you a link. One thing with linear actuators, the reason we don't use them even more, that, you know, they're not cheap. None of this stuff is. The more advanced you get into this, but one reason I don't use them for jaws is they are too slow. The linear actuators are much slower, but they're much torqueier. They have much more strength. So they don't work quite as... I wouldn't use them for a jaw servo. I want a jaw servo to be quick and crisp. In fact, I am... Actually, I don't have one handy. Moving into some high-speed servos that I'm going to try for the jaws. In fact, it is an HS 5565 that I'm using on this particular one. Super high speed, almost double the speed of a 425. And I haven't programmed them yet. I just got this built up. And Steve, in fact, I'm going to be using a Banshee board to build those. And I just got my Banshee board from Steve in the mail the other day. So it's sitting right here. Maybe tonight I get a little bit of time to start soldering that together. So I'm hoping that faster servo gives me even faster response time for my jaw. So I'm going to try that and see. But the actuators really are too slow. For a lot of my head movements, I like my heads to move fairly slowly. I don't like jerky 3-axis movements. I think it looks, again, you know, like somebody that's, you know, got a broken neck, and I don't like that. So the speed of the linear actuator is just fine. And I use, they usually come in 3 different versions, and I get the one that's the highest speed of the 3, but of course it's got the least amount of torque, but the torque it's got plenty. And so that works really good. So I've done a lot of starting to use those linear actuators for a lot of places where I need high torque, but I don't need high speed. Okay. Duty cycle. They do have a duty cycle, but again, for the type of stuff that I'm using these for, they're getting plenty of rest in between, so I'm never pushing the duty cycle. For those of you that don't know what duty cycle is, a lot of things, a lot of motors, a lot of actuators, servos, pneumatic compressors, You can't run them all the time like you can like a wiper motor. Wiper motor, you can run continuous rotation and run it all the time. They're designed for that, but a lot of them you need to let them rest in between. And I don't remember what it is on the linear actuators offhand, but I've never run up against it where that's been a problem. I used linear actuators. If you've seen my new witch scene, the witch and skeleton, the legs. I think it's the legs. Yes, the legs are being moved by linear actuators. So even with that movement, I haven't had any problem pushing up against the duty cycle. So that's actually a great prop to go look at and kind of compare. The legs, we just kind of wanted the legs getting a little bit of motion in. But the arms, we wanted to be able to bang really fast. So the arms are on pneumatics and the legs are on linear actuators. So you can kind of go look at that prop and see that difference a little bit. Okay, any other questions? I know I've gone over a little bit. So if not, I look forward to seeing you guys next week. Go over to the YouTube channel, subscribe over there if you haven't, to be able to get all the videos over there. If you have thoughts, ideas, constructive criticism, I'm certainly always open for that. Ideas for future things that you'd like to see covered. Make sure to go over to my Facebook page and post it over there, and we'll see if we can get that covered. So, okay, until next week, 5 o'clock Pacific, 8 o'clock Eastern, we'll do this again. So, guys, have a great week. Hope to see you building all week, and we'll see you next week. Thanks much. Good night.